Hello everyone. I hope you are doing well. Uh, Welcome to our new weekly video. All right, so today we'll be discussing how we can calculate present value for perpetuity. With and we will also see some perpetuity with the growth rate. All right, so for the perpetuity, the basic idea is there is no time frame, right? The cash flow is for forever. You don't have the exact time rate. So you can see if you the in the timeline there was no like t when we calculate the present value. So what we need here, we need the cash flow and we need discount rate. Once we have this one, we can easily calculate our present value for the perpetuity. Okay, all right. Let's see an example. What is the present value of $100 every year forever? So when you see the forever, that means you're doing a perpetuity problem, right? So if the discount rate will stay at 5%. All right. So we have uh, let's open an Excel sheet. Okay, so we have our cash flow, uh, which is 100, our discount rate 5%. So the rate is 0.05. So what should be the present value here? This is very straight formula, just cash flow over our rate, right? You don't need to come up with any period, any time here. So this 2000 is the present value for the perpetuity of this specific problem. Okay. So this is a very basic example for the perpetuity. Okay. Now the tricky part here. What if the $100 payments are received starting in 3 years? So there are like two composition of the problem, right? So if you go to the timeline, I would suggest you to always draw a timeline uh, on your sheet just to understand in which part you are calculating, right? It is very helpful to show the timeline when you calculate any present value. Okay, so in our question you can see it says it starts from the 3 years. That means this from this area, right? So you have to calculate the present value for the previous two period. So now you have t equals to 2, but we don't know the cash flow, right? We know the discount rate, we know t our time period, but we don't know the cash flow. So for the cash flow we have to uh, use the perpetuity problem. Once we have the value here, like at this here, like we have the c, then we can easily do our regular present value calculation to get the present value for first two period, right? So let's first calculate the perpetuity for. So here our cash flow. Oh, we have already done that in our first example, right? The same amount, 100 and the same rate. Okay, so that 2000 should be for each of the year, right? I mean, at that period, like at the three. So in that area, if you now go our like traditional present value calculation, if we have the present value at the starting of three, then we do our regular present value calculation, right? The discount rate, cash flow over um, 1 plus discount rate. And we have now our time frame, right? We need to want to calculate for the 2 years. So this 1814 basically your present value for this. Okay, all right. So here, if like in your question, if like you see like there are like 5 years, what you gonna do? Like we just simply write it here 4, right? Because when you have the value for 5 years with the perpetuity, then you have to go back like previous 4 years. So you just put 4 years, right? For 10 years, you just put 9 on T. Just you have to go back to the 9 years, right? So this is kind of tricky. You have to read the question very carefully. That is it the perpetuity for forever or there is any specific time frame given to you. All right. Okay. Then the next question is if there is a growth rate on the cash flow. If there is you have like the G for the cash flow, then the calculation we have to just adjust the growth rate with the discount rate. Other than everything is same. And also for the uh, like the starting in 3 years type problem, all will be same. So for growth rate, uh, let's solve this problem. Okay. The first payment is 1000. Let's write it again. C 1000, and there is a grow at 2% each year, right? So our growth is 0.02 and the discount rate is 7%. So our rate is 0.07, right? So what should be the perpetuity? We have cash flow and we have rate minus growth, right? So this 20,000 should be the present value for this growing perpetuity problem. All right. I hope it helps you a lot. But still, if you have a question, feel free to reach me. Thank you.